Okay, Assalamualaikum and good morning. Okay, so today we're going to continue with the remaining part of topic number 6 on normal distribution. So in the last class, we have discussed how to convert from X into Z distribution, okay, using the simple formula X minus mu divided by sigma. Okay, so why we call it Z distribution? Because in order to calculate the probability of a normal distribution, we need to convert into the Z value so that we can read from the table or use any online calculator that uses the Z distribution formula. Okay, so and in last class, I've shown you how to refer to the table, and bear in mind that the table only gives you the area from 0 to the Z value. Okay, so for example, if your Z value is 1.50, so basically the area is from, you are reading from right to left until it stops at 0. So the area on the right is not covered in the table. So for example, if you want to calculate the value of Z more than 1.50, it will be 0.5 minus 0.4332, so that you can get the remaining of the area on the right tail of the normal distribution. So we discussed that on last Monday. Okay, and we also went through some of these examples. So I also remind you that whenever you draw a normal diagram, the most important part is to draw your normal distribution curve, okay, and then followed by the horizontal axis, and divide the graph into half, okay, and the center we mark as 0 because the mean is always 0, and the value on the x-axis will represent the value of Z that you convert from X into Z, okay, based on the calculation that you made based on the question. Okay, so we went through those examples before, and one of the examples that we did last Monday was to convert or to calculate the probability between 790 and 1000, whereby these two values, when you convert, we get the value of negative 2.1 until 0. Okay, so that is the range, negative 2.1 until 0. So, and I also mentioned that whenever you want to calculate the probability, always write in terms of first the X value. Okay, if you are calculating in between two values, it will be X, the lower and the upper value, and then you convert that value into the Z value, okay, in between two values. Okay, so for example, this one, negative 2.1, okay, okay, so, but you get the idea. So we discussed that one last Monday, okay, and then we also went through this this last example, less than 790, whereby you want this the area on this on the left side of the tail in the normal distribution, this area. Okay, so because the question requires you to calculate P X less than 790, okay, so in this case there's only one value, okay, not in between two values. Okay, so when you are only calculating only one value of X, meaning X less than what value or X more than what value. So again, the same procedure, convert into Z, okay, less than what, so 790 convert into Z, you get negative 2.1. Okay, so again, remember from the tip last Monday lesson, whenever you want to calculate the probability, always refer to first the direction of the equality, less than or more than, and secondly is the value of your Z, whether it is negative or positive. Okay, so less than meaning the area towards the left of the distribution. If more than, then you are looking area to the right of the Z value. Okay, so less than meaning less than 2.1, negative 2.1, so it will be the area on the right side of the tail. But because your table only provides positive value of Z, so this value on the left is equivalent to the value on the right, meaning that if you were to reverse this sign, it will be Pz. Okay, this is also equal to the area of Pz less than 2.1, negative 2.1 is also equivalent to Pz more than positive 2.1 or just 2.1. Okay, so it will be, so this blue equation is this one here. Okay, so the one, so when you refer to the Z table, you refer to the value of 2.1. Okay, that's what we also seen last Monday. So 2.1, you get 0.4821, which is the area, the blue area here, 0.4821 from 0 to Z. So you want the remaining area on the right, so you need to minus by 0.5. Okay. So today we're gonna finish up with the remaining of the examples, and I will show you how to do some of the easier, some of the questions from the book, and also use from the table in the book, and also to use the online calculator. Okay, it's better to know both methods because sometimes it is much faster to use the table rather than using the online calculator, because it is rather if you have several things to estimate. Okay, for me, because the formula is very simple and straightforward, x minus mu divided by sigma in order to get the z value. And once you obtain the z, then refer to the table to obtain the corresponding probability value. So here, in this example, you want to find the probability between 840 and 1200. And again, as usual, start by writing the question in hand in terms of equality sign. So px, because you are calculating between the two values, so there will be two values left and right. So this will be 840. Okay, and the right one will be 1200. Okay, so when you convert into z, okay, I'm just referring to this value. So 840 correspond to negative 1.6. So just follow the sequence on how you write the equation above. Okay, so this will be Z. So 840 is negative 1.6. So second one, 1200 will be 2.0. So you want to calculate between one negative value and one positive value. So what you can see here, okay, so it will be between negative 1.6 up to 2.0. Okay, so the first thing is to solve the one in the positive sign first, because you know that PZ less than 2. If you take this part here, so it will be Z less than positive 2. Okay, so 2, so meaning this part, you are referring to this area. Okay, in red. So you know that from the table, 2.0, you can refer directly from the table. 2.0 is 0.4772, the one highlighted, this one, in this area. Okay, and then for the second one, okay, your Z is negative 1.6. So again, because the table is symmetrical, so if you were to calculate between from negative 1.620, it will be as though you are calculating 1.620. It's just the mirror image of this one, of this area on the left. So what you can do is just read the table that shows 1.60, which is 0.4452. So this is this area. So by right, you are getting the area on the right, but since you are referring to the area on the left, so it's just the mirror image. So the answer will be the sum of these two, 0.4452 plus 0.4772. So that will be the answer for this question. Okay, the sum or the total probability, this plus this. Okay, so and what if you okay, so we have seen examples whereby you are calculating between two values on the, for example, okay, the first one, okay, you are calculating between two positive values, meaning between 0 to 1.0. I mean, 0 is also considered, I mean, we can call it positive as well if you want. Okay, and then we also look at calculating between 1 negative and 1 0. Okay, between negative 2.1.0, which is almost similar to this one. Okay, between 0 to positive 1. Okay, because if you are calculating between negative and 0, it's just you are looking from the right side, is just between 0 to 2.1, whereby the solution is just reading 2.1 directly and you can get the answer. And the next example is between one negative and one positive value. Okay, so again, if one negative, one positive, the solution will just be directly referring to the Z table, both of the corresponding value, 2 and 1.6, and simply adding them both. Okay, but again, do not memorize this way. You need to understand. That's why whenever you are solving for questions, when it comes to calculating probability under the curve, the best way is to draw the curve and highlight the area under the curve that you want to calculate. Then from there, you should know how to read the table. Okay, but this example is one negative and one positive, and the way we solve is simply by adding directly the value of the probability from the table. Okay, so how about if both are positive? Okay, for example, this one, 1150 and 1250. Okay, so when you convert into Z, you will get both of the Z value in the positive region. Okay, so one Z value is 1.5. Okay, 1.5. The other Z will be 2.5. So both of the Z are in the positive region. Okay, as what you see here, 1.5 to 2.5. Okay, so the area that you are interested to find is just this small area, meaning just between the two positive areas. Okay, so how do you solve when you are when you have a question like this? Both are positive, or it could be both are negative. Okay, meaning it's just the mirror image of what you see here. Okay, so if both are positive, it will be similar if both of the Z value are negative values. Okay, but since the question is referring to positive Z, so let's look at how we solve for when both are positive. So I think you can get the idea now. Okay, even though I haven't shown you the solution from the next slide, but I think by now you should get the idea. Your table only gives you from if you want to read this way, it is reading from right to left until it stops at 0. So for example, 2.5, if you refer to 2.5 from the table, okay, so 2.5 will be until 0. So by right, 2.5, if I mark this one in the area in blue, it will be this area, 2.5 until 0, if you read from the table. Okay, likewise, if you refer to 1.5, it will be this one, the area, this is the area, 1.5 until 0 as well. So so that leaves us with this remaining area, okay, the one that we want to calculate, which is the one in yellow. Okay, so I think you get the idea. If you want to solve for this problem, just simply referring to the value of 2.5, whereby it will be the area in blue, minus with the area of 1.5, which is the area on red, which gives you the area in yellow, or the solution to the problem. Okay, so that's how you solve when both are positive or both are negative. Okay, so 2.5 gives you 0.4938, okay, whereby 1.5 gives you 0.4332. So the solution will be, as in this slide, you can see that it will be 0.0606. You obtain this by taking the difference between 0.4938 minus by 0.4332 gives you 0.0606. Okay, so that would be the solution how to solve when both are positive, or if you have both are negative, this will be the same way. Okay, take the value of the Z and just simply take the difference. Okay, but if one negative, one positive, like the previous example, this one, okay, you need to add them both. Okay, so basically you can just imagine there could be only 2 or 3 possible scenarios when one negative, one positive, like this, whereby the solution is to add both of the values from the table, or if both are positive or both are negative, whereby the solution would be to take the difference between the two values from the table, or the one which is the one that we did, if the value is pointing to the left side of the tail, like this one, okay, less than a negative value. For example, if you're referring to this value, or to the right side of the tail. For example, you want to calculate P Z more than, let's say, 2.1. Okay, so if you want to calculate PZ more than 2.1, let's say this is 2.1. So let's say this is 2.1. So more than 2.1, meaning you want the area to the right of 2.1. So that will be this area. So first, focus on the sign of the sign of the equality, whether it's more than or less than. So more than, always pointing to the right. Okay, and then look at the value of Z. So if Z is positive, so you are looking at the right side of the positive value. Okay, so that will be the area, meaning you need to refer to 2.1 from the table and you need to subtract by 0.5, just like this one. Okay, so I think we have covered most of the scenarios or the examples from the. Okay, for this example, I will leave it first. Okay, we may get back to this solution once we have done with some of the examples. Okay, and last, okay, we already discussed this one in the previous topic on the empirical rule. Okay, whereby the 68% will be 1 plus standard deviation, 95 will be 2 standard deviation, 99% or 100, almost 900% will be 3 plus standard deviation. Okay, and I'm sure you are still fresh from the test or the test one that we did previously. Okay, whereby I think you have some questions on this empirical rule. So since we already covered this one in the previous chapter, so we are not going to discuss this one again. Okay, I also have given you the link for previously the same calculator website for Z to calculate standard deviation. Okay, so in that website, okay, the one that we did previously is the standard deviation calculator for population or sample. Okay, in the same website, you can also calculate the Z score calculator. Okay, so this one gives you the X value, the mean value, and the sigma. Okay, if you recall from the formula, how to convert from X into Z is basically X minus mu divided by sigma. So you need X, mu, and sigma. So once you key in, you will be able to get what is the Z value. Okay, and automatically it will gives you all the possible solution if the value of X is less than, more than Z, between 0 to Z, between 1 positive, 1 negative. Okay, so you have, and also if you want to calculate between two Z values. Okay, so what the solution for this one is similar to this example just now, whereby you have 1 negative, 1 positive, or both are positive. For example, this one, you know that the solution will be, I mean, the value of Z is negative 1.6 and 2.0. So for example, just put here negative 1.6 and 2.0. Okay, and then you will be able to calculate the value, okay, between negative 1.6 and 2.0. So the solution would be 0.92245, okay, which is what you will get here. I mean, just to clarify, verify, okay, 0.4452 plus 0.4772. So gives you 0.9224, which is similar to this one. Okay, so this one, probability between two Z values, you must know what is the Z value first, and then you can key in the solution here. Okay, and you can get directly from the calculator. Okay, likewise, for example, like this one, the last example, okay, between two positive values or between two negative values. Okay, so this one between two positive, so the lower will be 1.5. Okay, so this will be 1.5 positive, and the other one will be 1.5 and 2.5. Okay, so we calculate, we should be able to get 0.060598. Okay, which is 0.06. The answer is 0.0606. Somewhere 0.0606. If you round up to 4 decimal places, it will be 0.0606. Okay, which is the same here. So you can use this one to get directly the value from the calculator between two Z values, or you can, if you only are referring to, if you want to, because I think it's better to calculate, to convert from X into Z manually, because the formula is very simple. X minus mu divided by sigma. Okay, mu is the population mean. So when you refer to the question, you should know what is the value of the population mean or the mu. Okay, it is stated clearly here. the income follows with the mean of, so mean 1000 is referring to the mu. So sigma, I think is very straightforward. Standard deviation will be sigma value. So the question that you want to calculate will refer to the x value. Okay, so let's take a look at some of the questions. Okay, so the one that I marked in red, okay, so there will be 4 questions for you to submit latest by Friday afternoon, okay, similar to what we have done before. So I've marked 4 questions that you need to do: 14, 16, 18, and 20, okay, on page 201 in the textbook, and also page 199, okay. So this will be in chapter 7 in the textbook, okay, under continuous probability distribution. So you can see here, page 199, 14 and 16, page 201, question 18 and 20, okay, page 201, okay, question, okay. So I'll give you, or show you how to, I mean, for me, the best will be to use the table. Okay? Although it is a little bit slow, but at least you learn how to refer to the table rather than skipping directly to the online calculator, because I want you to calculate this thing manually. At least learn how to calculate the Z value. Okay, because later in the future syllabus, topic 7 and above, okay, so you need to solve this thing manually because you need to do hypothesis testing. So that the best is to derive the value of the Z or the whatever statistics value using the manual formula. Okay, because I think calculating this online will take you longer because you need to key in one by one rather than you solve this using your own calculator will be much faster. Okay, so let's take a look at question number 13. Okay, so I already opened 2 side by side. Okay, so you can see the solution here. The one here on question 13. Question 13 and 15. Okay, so both have answers at the back. The one that I want you to do are the one without the answers. Okay, of course. So let's look at question 13 first. Okay, so you are given the mean of 20. Okay, which direct. So this one is referring to the mu and sigma of 4.0. So the first is simply calculate the Z value. So recall Z value is obtained by x minus mu divided by sigma. So in this question, you want to calculate the Z value, meaning just get the Z value first when x is 25.0. Okay, since I already opened this one, okay, so I just key in 25, the mu is 20, the sigma is 4, correct? Okay, so mu is 20, sigma is 4, okay, mu is 20, sigma is 4, and x is 25. So the corresponding Z value is 1.25, which is what you will get here, 1.25 you obtain by 25 minus 20 divided by mu, divided by sigma, which is x minus mu divided by standard deviation. Okay, the second question, the answer is 0.3944. Okay, so what is the question? What is the proportion or the probability between 20 to 25? Okay, bear in mind, both of these are the x value, okay, not the Z value. If you want to use the calculator, okay, so you need to key in, you need to know if you want to use, for example, this one, okay, between 2 Z values, you need to get the Z value first before you can key in. Okay, so this is not directly key in the value of x, you will not get the answer. I mean, you will get a wrong answer, of course. So if you want to get the Z value, one way is to type one by one here, meaning get the Z value when x is equals to 20 and get the Z value when x equals to 25. Once you obtain both of the Z value, then you can key in the in this one between the 2 Z values. Okay, so that will be the solution to, I mean, one way to do it. Okay, this one, if you are only looking at one Z value, for example, x is more than or less than. Okay, so that will be the way to calculate. Okay, so we know that, okay, what is the proportion of population between 20? So when x is 20, we know that 20 minus mu, 20 minus 20, already 0. So we can know that Z value for 20 will be 0. Okay. I mean, no need to calculate. Also, you can figure this one in your head. Okay. So 20, x minus mu over sigma. So 20 minus 20 divided by 4. Okay, you will get 0 here. So 25, we already know that. Question A, 25 just now is 1.25, correct? Okay, from the answer just now, 1.25. So now we know that 20, the Z value will be 0. 25 will be 1.25. So you can use this calculator now. It will be 0 and 1.25. So simply calculate, and then you should get the value of between 0 to 1.25. Okay, bear in mind this is actually Z, okay, not X. So it will be 0.39444. Okay, 0.39435 or 0.3944, which is correct lah, 0.3944. Okay, and lastly 0.3085 is the answer. Okay, what is the proportion? Less than 18. Okay, so again, first you need to get what is the value of Z from when we convert from X. Okay, so 18 is the X value. Okay, so recall that. Okay, so you want to calculate the value of Z, so 18 will be the X value. Okay, and the rest is the same. The mu is 20, the sigma is 4. So the value of Z, okay, that correspond to 18 is negative 0.5. And you can see here that, okay, when you key in that value, the calculator provides you with three possible solutions. Well, one is when X is less than the value of 18, more than 18, and between 18 to 20. Okay, 20 here is the mu value, which is when you convert, it will be 0. Right? Okay, so the question wants you to get less than 18. Okay, so less than 18 is what? It will be this one, less than 18. So the answer is 0.3084, which is what you get here, 0.3085. Sama 30845. Okay, you round up, 0.385. 3085, which is same one here. Okay, so okay, so how do you refer to how do you get this one from the table? Okay, if you were to calculate this manually, okay, so you can see that when you convert from X into Z, your Z will be negative 0.5. Okay? If I were to draw this, okay, in the table, I mean in the normal diagram, okay, so negative 0.5 will be somewhere here. Okay, correct? It will be somewhere here, negative 0.5. Okay. Okay, so the question wants me to calculate less than, okay, less than 18, okay, which is, so less than 18 is what? So if we mark this part by, okay, so this will be 0.5 line. So less than that will be pointing to the left, correct? As I said, whenever you want to solve the question, first refer to the equality sign. So you want to calculate less than. So less than is anything to the left. So to the left of 0.5 will be this area. Okay. So to the left of negative 0.5, it is similar to as though you are calculating to the right of 0.5 positive. Okay. If you recall from the slide, it will be the same one as what you did for this question. The one that you calculate, yeah, this one, less than 790, whereby you get negative 2.1. So less than 2.1 is the area on the right here, the small area, gray area, or which is similar to the area on the right, okay, more than 2.1. So you obtain by 0.5 minus the value from the Z table. So this is also what you find here, okay, negative 0.5, okay, I mean, the value of Z will be negative 0.5, but when you read the table as 0.5. Okay, so 0.5, I think from this one you can see, okay, 0.5. 0.5 is 0.1915 here. 0.5 will be 0.1915. Okay, so that will be, okay, so where does this area refer to? This one, 0.1915. So this value will be between 0 to z, but you want the area to the right side of this area. So the solution will be 0.5, okay, minus with this value here. So that actually provide you with a solution, which what you get here, 0.5 minus 0.1915. Okay, so I think what the rest of the exercise that I want you to do, okay, will be very similar to uh, the rest, okay, of the questions, okay, whether it's between more, for example, like question 14, okay, which is similar to 13. Okay, question 16 will be similar to 15. So you can do the 15 first. You can check the answer at the back, whether you want you to use calculator, your own calculator, or use the, the online calculator. Then you can do question 16. Okay, similarly, the next two questions, 18 will be very similar to 17. Okay, and likewise, question 19 will be similar to 20. Okay, before that, okay, before I end our video for today, if you look at 20B, at least 23. Okay, so you recall that I mentioned in the previous lecture on Monday, okay, the word at least by equality sign, it will be like this. Okay, more than is like this. Okay, but in continuous distribution, whether it's more than or at least, both are the same. Okay, it has no difference. So even though B is at least, okay, you can just use this sign, meaning X is more than 23. Okay, so no need to put the at least greater than 23. Okay, so like this one, exceed, it will be more than. Okay, between, it will be, okay, like this lah. It's the same one that you've been doing. So I just want to point out question B, because when you look at the word at least, okay, bear in mind it has no difference between more than. Okay, because in continuous, there is no difference between two of the symbol, whether less or equal to or less than. It is the same as it is the same, and the same goes with more than or and also at least. Okay, so I will put up the link in your OL. Okay, so submit as usual. Give the screenshot from the solution, whether you are using the online calculator or if you are doing this manually. Okay, for example, if you are doing this manually on a piece of paper, okay, and you want to show the solution, where you want to highlight the area under the curve, just what you see from the slide here. Okay, so actually I would prefer like that. Okay, you want because if you use the calculator online, of course the calculator does show you the area. Okay, but this one is automatically generated from the system. So what I would like to see is you do this manually on a piece of paper and just take a snapshot using your phone and post and put the image on the Word file, and save it as a PDF and submit online for the 4 questions. Okay, or you want to scan whatever way that you want to do, or if you want to use the online calculator, it's also possible. Okay, but I would like to advise you from early on. Okay, if you use online calculator from this topic onwards, you might have problem to understand the future topics. Okay, I'm only showing you the tools that you can use. Okay, just to speed up your calculation, but provided that you know how to calculate this manually. Okay, because the skill that you get when you learn to refer to the table, the Z table, and calculating this thing manually, okay, will be very useful when you want to handle, okay, tougher questions in the future topics, okay, topic 8, 9, and 10. Okay, so my advice, do it. You can check your answer or your solution using the calculator, but solve the problem manually. Okay, meaning how you want to answer will be basically similar to what you see here. Okay, so you need to draw. The main thing is I want to see the normal curve, and you shade the area under the curve, the area that you are looking for to solve. Okay, and take note that the main thing that you need to draw is the normal diagram, the horizontal axis. Okay, and then cut the graph into middle, which is marked as 0. 0 will be the Z value. Okay, only provide the value of the Z, no need to put the value of the X value. Okay, and then the corresponding value of Z, okay, and then also shape the area under the curve. For example, if you are calculating between one negative and one positive, so the area will be this part, okay. So just at least I know that you understand the concept of finding the area under the curve, okay. So that's all for our session for chapter number 6. Okay, in your textbook it will be chapter 7, okay, but in your syllabus it will be topic number 6. So again, the question will be page 199, question 18 and question page 201, question 18 and 20, and question 14 and 16, page 199. Okay, so thank you. Assalamualaikum and good morning.